Welcome to the last video in this series. In this video, we are going to talk about cross tabulations, correlations, and scatterplots. This is a little bit of a longer one as well, so without further ado, let's go ahead and jump into the video. Previously, we looked at univariate variables, which was one variable, and bivariate, the bi is two, like a bicycle, has two wheels, and so bivariate is we're looking at two variables. So we are going to analyze this data three different ways. We're going to look at crosstabs, which are good for categorical variables. We're going to look at correlation coefficients, which are good for continuous variables, and scatterplots, which are also good for continuous variables. For this part, we are going to make a crosstab or a cross tabulation. And so we're going to use a frequency distribution where one variable is going to be that race ethnicity that we combined, and the other variable is going to be the school location, and it's going to be either urban or city. And this is called the cross tabulation. So let's go ahead and do that. We're going to go up to Analyze, then we're going to go down to Descriptive Statistics, and then we're going to go over here to crosstabs. Then it opens to this and we see that crosstabs. And if you remember, we did have one that we started with the pie graphs in a couple videos ago. That was the student's race and ethnicity, where it had all the adjectives describing it, and then we combined it. So that's the one that we want, is we want the combined down here. So we're going to click on that for the rows, and then for our columns, we're going to find the school, and it's either going to be the urban or city. So let's go ahead and find that. So it's right here, so we're going to click on that, and we're going to put that as our columns. Then we're going to come down and click OK. And this is what we will end up with. So we have that single descriptor here, and then we have that school, urban, city up here, and we can see where it's divided up. So we have urban, suburban, rural, and then our total. But it's a little bit easier to read and interpret as percentages. So that's what our next step is going to be. So notice that here they're in frequencies, and so our next step is to make them into percentages. So let's do that now. So this time we're going to go up to Analyze and Descriptive Statistics like we've been doing. Go to Crosstabs again. Notice it has our data in here. This time we're going to go over to where it says Cells over here, and we're going to click on that. And notice how it has counts and percentages. So we want our percentages to go in our column, and then we want to get rid of our counts. So sorry if you hear a little bit of background, my dog just came over to visit. So if you hear a little bit of movement, that's my dog. All right, so next we're going to hit continue, and then we're going to click OK. And now we have this. So we have our race ethnicity combined over here. These are our rows. Our columns are still urban, suburban, rural, and then we have percentages. So again, for the most part, percentages are more intuitive to people than just numbers, because the raw number just doesn't carry as much meaning. So it's pretty common to put our data into a percentage. Next, we're going to talk about correlations. So a few things that you need to know about correlations. Whenever you hear the word correlation, think about relationship. So correlations are going to tell us or describe the relationship between two continuous variables. I'm going to show you some visuals in a minute, but for right now, just think that anytime you hear correlation, we're going to think about a relationship between two continuous variables. For our correlation coefficient, it can range from -1 to 1, and it has a direction and it has a strength. So let's go ahead and look at that a little bit deeper. So first, let's think about the direction and the strength. So the direction is that as our x-axis, or our variable on the x-axis, increases or decrease, the y-axis will do the opposite for a negative, and the same for a positive. So for example, it is very common that height and weight are positively correlated. So as height goes up, weight would go up. Let's say that work and sleep is negatively correlated. So let's just say that the more hours we work, the less hours we sleep. You might be able to resonate with that. Then the strength tells us the strength of the relationship. the closer the coefficient is to 1, the stronger the relationship. If our correlation coefficient is 0, there is no relationship. So 1 is a perfect relationship, 0 is no relationship, and then the range between. So then we can look at this, and so it says the size of the correlation coefficient, so 0.8 to 1, very strong, or 1 obviously perfect, 0.6 to 0.8, strong, okay, and then it goes on moderate to weak to none. There are differing opinions about this, but as a general rule, you can kind of go with something like this. We are going to get to scatter plots in a minute, but I do think it helps to kind of put what we were just talking about into some sort of visual representation. So I just want to look at this for a brief minute to just talk about the relationship again, the correlation. So remember we talked about our y-axis and our x-axis. So let's take that first example that we used, which was the relationship between height and weight. So if our height was down here on our x-axis and our weight was on here on the y-axis, we would see that as our height increases, the weight also increases. So the top row represents positive relationships to various degrees of strength. So the more tight these are, the stronger the relationship, and the looser the relationship. Okay, and we can even see that by our numbers down here. This is essentially no relationship, where it's kind of scattered all over the place. And then these two are negative. So this might go with the more hours that we work. So the more hours that we work, then the less sleep that we get. And so we notice that the easiest way to look at it is like this. So if we work only in a few hours, we get lots of sleep. If we work a lot of hours, we only get a little bit of sleep. So the scatter plot is a great first step when we're looking at correlations to help us to visualize the relationship, if it's positive or negative, as well as the strength. But we will get back to scatter plots in a minute. Let's continue on with correlations. Now let's say we want to know the relationship between the amount of hours somebody works and how they perform on a standardized test. So to do this, we are going to run a correlation test. So we're going to go up to Analyze. Then we're going to go down to Correlate. Then we are going to go over to Bivariate because we're just going to look at two variables. So we're going to click on that and it takes us to this screen here. So now we're going to put in our hours worked per week. And again, we're looking at two continuous variables. So we're going to just kind of scroll down until we see those rulers. And we're going to look at a test score, which is also a continuous variable. So we'll click on that. Then notice down here we have different types of correlation coefficients. So when we're working with two continuous variables that are both interval and or ratio, we want to use that Pearson's. So when we're looking at two variables, when one is continuous and the other is ordinal, which is something that we actually can do on a correlation, but we have to use that Spearman. So we are just for this lesson sticking with two continuous and kind of sticking at this basic level here, but later in the semester we actually will talk about Spearman because that is actually something we can do a little bit of a workaround when we have a continuous and an ordinal variable. So next we're going to click OK. So let's look at what we have here. So we have our hours worked per week and we have that standardized test score. Then over here we have our Pearson correlation and the significance, a two-tailed test. We'll talk about significance testing in a little bit. And then the N is always our sample size. Okay, and then we have it again here. Then our columns are hours worked per week and standardized test composite score again. So notice that it's kind of like Battleship is what I always tell people, where we kind of go our row across and our column down into a cell. And so notice that our hours worked per week and our hours worked per week is 1 in our Pearson correlation because it's a perfect correlation because it's the same variable. But what we really want to know is hours worked per week and the standardized composite scoring. So we want to look over here. So the negative sign is telling us that it's a negative relationship. So that would mean the more hours per week somebody works, the lower score they would receive on this test. Then you can also notice that it has those two little stars. And if we look down here, it says the correlation is significant at the 0.01 level on that two-tailed test. So again, that's stuff we're going to get into later in the semester. But in case you're wondering what the symbols are, that's what that is. So then, of course, this is our sample size, like I mentioned before. And then if we take a quick glance down here, we see that Pearson's correlation, again, with the standardized test. If we come over here, a standardized test, it's a 1. It's because it's the same measure, so it's perfect. Then we have the standardized test score and the hours worked is that negative 0.29, which matches up here because we're only looking at 2 variables. That is how we run a correlation analysis and then how we interpret the table. Next, we're going to look at scatter plots. Last up, we have Scatterplot. We are going to go up here to graphs. We're going to go down to scatter. Then notice we have some options. We are going to keep it to a simple scatter. We're going to hit define. Then it opens up to this view. And so we need to put in our x-axis and our y-axis. Our x-axis will be hours worked per week. So that should be here. We're going to click on that for our x-axis. And then our y-axis is going to be that standardized test. So we're going to come down here and do that. Okay. I don't know. For some reason, I always think about the x-axis first. But if it's easier for you to think top, bottom, do it whatever order you want. Just make sure that they're in the right spot. That's the most important thing. All right. So now that we have that, we're going to click OK. And then this screen will pop up. And so there we have a scatter plot. And it is a little bit easier to interpret when we have a line of best fit. So let's go ahead and do that now. So we're going to double click. Then we're going to right click. So notice just like that bar graph we did a couple videos ago, it highlights this. And then we are going to add fit line at total. So let's go ahead and do that. Click this right here. And we want linear. So we're going to click that. Then we're going to click apply. Close. And here we have it. So notice our little line is negative. It's kind of slipping down. But also keep in mind that the relationship was not that strong. So let's look at that number. So if we scroll back up to our little correlation table over here, it was a negative 0.029. So if we round it up, it'd be a negative 0.03, which is very close to 0, which is signifying that there's essentially no relationship. So the relationship is negative, but it is not a strong relationship, and it's really approaching the no relationship status. And so that's why this line is relatively flat, and if anything, it's just sloping downward just a little bit. But that's the reason why. And so this helps us kind of just know going into it what it should look like. And now we have our visual, our line of best fit. And one last thought on scatter plots and correlation. So the correlation can only tell us 2 things. It can only tell us the strength and the direction. So with each of these, we see different levels of strength, like we mentioned before, and we see the direction. And it can give us a line of best fit, like we saw here, where this line going across is our line of best fit. But its limitation is talking about the slope. Let's look at a slide that shows us slopes. So here we have 3 scatter plots, and all of these have a correlation of 1. But notice that the slope of each of these is different. That's where regression comes in. And we will talk about regression, but it will be towards the end of the semester. So let's go back to this page where we saw our correlation was that 0.029. So we know that the direction is negative. There's a negative relationship. And we know that the relationship is weak. So it's a negative, weak relationship. But what we don't know is the slope. And we won't know the slope until we start running some regression models, which, like I said, we will do towards the end of the semester. But for right now, what we want to know is that scatter plots and correlations will tell us the direction and will tell us the tightness or the strength of the relationship, but it will not tell us the slope. We will get to that very, very soon. So stay tuned for that. And that's it. So I hope all of these videos were very helpful to you. And just as another reminder, I do host office hours several times a week. So if you feel like you need a little bit of extra support, please don't hesitate to stop by in my Zoom room. And I hope to see you very soon, either in Zoom or in another video. Bye for now.